You know how as we get older, our sleep patterns can get a little, weird? We all kind of expect that. But what if those changes weren't just an inconvenience? What if they were actually a sign of something much more serious? For people with Alzheimer's disease, this connection between sleep and the brain is an incredibly complex and troubling puzzle.
So that brings us to the big mystery, the question researchers have been wrestling with for years. It's a real chicken or the egg situation. Does Alzheimer's come first and destroy a person's ability to sleep, or does a lifetime of poor sleep actually help pave the way for the disease? Let's dig into the science and see if we can find an answer.
All right, to get to the bottom of this, we've got to look inside the brain itself. We're going to follow the biological clues to see what's really going on with the brain's internal clock.
Okay, so first things first, we all have this built-in 24-hour clock called the circadian rhythm. It's the master programmer that tells your body when it's time to feel tired and when it's time to feel awake. And where does this master controller live? In a tiny little spot in the brain called the suprachiasmatic nucleus, or SCN for short. Think of it as the conductor of your body's entire daily orchestra.
And here it is, our first major clue. Scientists have discovered that in a brain with Alzheimer's disease, the actual cells inside that master clock, the SCN, can get damaged. Now, if the conductor of the orchestra is struggling, the whole performance is thrown into chaos, right? That's what happens here. It's why people with Alzheimer's often have such restless nights and feel sleepy during the day. The disease is literally attacking the brain's timekeeping center.
Now let's meet one of the main villains in this story, a protein called beta-amyloid. In a healthy brain, this stuff is just a waste product that gets cleared out while we sleep. No big deal. But in Alzheimer's, it's a huge problem. It starts clumping together, forming these sticky, gunky plaques that basically clog up the works and block the communication lines between brain cells.
So how does this connect back to sleep? The link is frankly pretty staggering. One study found that after just one single night of bad sleep, the levels of this beta-amyloid protein in the brain jumped by 5%. And this isn't just happening anywhere. It's building up in key areas that are really vulnerable to Alzheimer's. Why? Because our brain's nightly cleanup crew only comes out to work when we're in deep sleep. And there's a second villain, another protein called tau. Now normally, tau is one of the good guys. It's like the scaffolding inside our brain cells, keeping everything stable and strong. But in Alzheimer's, something goes terribly wrong. The tau protein collapses on itself, forming these toxic tangles inside the cells, and that is a clear, undeniable sign of damage and cell death.
Okay, if you thought that 5% increase in beta-amyloid was bad, get ready for this. Just one night of sleep deprivation can cause tau levels to shoot up by as much as 50%. 50%! Let that sink in for a second. A single sleepless night lets these two incredibly harmful proteins build up at a truly alarming rate.
Okay, let's recap. We have our clues, a broken brain clock, and two dangerous proteins that multiply when we don't sleep. Now, it's time to put all the pieces together and finally solve our sleep mystery. So, the answer to our big chicken or egg question? It's not one or the other. It's both. Turns out, Alzheimer's and poor sleep are locked in a devastating feedback loop, a vicious cycle where each one makes the other worse.
Here's exactly how it works. Step 1. Alzheimer's starts to damage the brain cells in charge of sleep. Step 2. That damage messes up the sleep-wake cycle, leading to fragmented, poor-quality sleep. Step 3. Because of that terrible sleep, the brain's nightly cleanup crew can't do its job of clearing out toxic proteins like beta-amyloid and tau. And finally, Step 4. Those harmful proteins build up, which causes even more brain damage, speeding up the Alzheimer's. And then the cycle starts all over again, spiraling downward.
Understanding this cycle is one thing, but what can actually be done about it? Let's shift gears and talk about some practical, real-world strategies that can help improve sleep for people living with Alzheimer's.
This really all comes down to something called sleep hygiene. Basically, simple routines that can make a world of difference. On the helpful habits side, stuff like getting bright sunlight first thing in the morning is absolutely crucial for resetting that internal clock. And on the things to avoid side, it's so important to steer clear of things like caffeine and alcohol, especially later in the day. Even the timing of certain medications can matter. You might need to talk to a doctor about taking some meds earlier so they don't interfere with sleep.
And here's a fascinating and really simple tip for you. Research is starting to suggest that your sleeping position actually matters. Remember that cleanup crew we talked about? Well, its official name is the glymphatic system. It's basically the brain's plumbing, and it seems to work way more efficiently when you're sleeping on your side. It's a small change that could make a real difference in supporting that vital brain cleaning process. Of course, managing sleep challenges isn't something a patient can do alone. Caregivers play an absolutely essential, critical role in creating an environment that's safe and promotes rest. So let's look at how they can help.
For caregivers, these are some really concrete things you can do. That consistent routine is number one for sure. It's also so important to rule out other problems, like sleep apnea, which could be making things worse. And simple things can have a huge impact. Just keeping a clock visible can reduce a lot of confusion if they wake up in the middle of the night. And if they do get up, a calm voice and very low lighting is the way to go. Blasting on a bright light can completely derail their fragile sleep cycle.
So if there's one thing to take away from all of this, it's this. Sleep is not just passive downtime. It's an active, essential, biological process. It is literally the time when our brain takes out the trash, organizes memories, and repairs itself for the next day. It's brain maintenance.
And that leaves us with a final, really powerful question to think about. When we see just how critical sleep is for clearing out the exact proteins linked to Alzheimer's, it forces us to ask, could protecting our sleep be one of the most powerful and accessible tools we have for protecting our brain health for our entire lives?